Hello and welcome to the lesson in science called Force and Pressure, where we will be learning about force in Standard 8. Now if you see this little image at the side, you will see that the ball only goes into that form when force is applied on it. What is force? Some simple explanations.
What is force? Force is a physical cause that changes or may tend to change the state of rest or the state of motion of an object. For example, a bottle at rest moves due to force applied by a person.
Force, a strength or energy exerted by an individual. It is an active power of nature. Force could be a push, a pull, or a resistance. Forces are needed to make things move. It can also make things speed up, slow down, or stop moving. For example, walking is possible only if the push force exerted by one is greater than the force of friction present between our feet and the ground. The thumb pin, a type of force used while pressing the thumb pin against the board, is the push force, whereas the type of force used while extracting the pin from the board is a pull force.
So a force can be defined as a push or a pull on a particular object. You can either push or pull, and when you are pushing or pulling, that is defined as force. The use of force needs interaction between at least two objects. You cannot push a table without interacting or touching it. Similarly, you cannot pull something without interacting or touching that object. Some examples: when someone pushes a car in a particular direction and the car moves in the direction of the applied force. Or if you kick a ball in a particular direction or pull or push a table. All these are simple examples of force. So we are learning about force in this unit. Let us see how we can look at force with regards to pressure. Now, force is the pull and push action resulting in the speeding up or the acceleration or the movement of the object. Whereas force acting upon a certain area perpendicular in direction to its surface is called pressure. Like suppose I am hitting a nail at 90 degrees into the wall. That is pressure. The unit of force is Newton and is represented by N, whereas Pascal is the unit of pressure represented as PA. Now force is a vector quantity, which means it has direction in addition to magnitude. So when we are weighing something, okay, that thing has magnitude. That means how much of the thing, as well as it is going in the downward direction. Therefore, it is a vector quantity. So force is a vector quantity, whereas pressure is a scalar quantity, which means it has only magnitude and no direction. And speed is a scalar quantity, like pressure. Now, force, the velocity of an object can be changed with the application of force in one direction, whereas pressure on an object won't change the direction of the object. Formula for finding out force is area into pressure, whereas the formula for pressure is force upon area. picture, the first person is carrying something. The second one is pushing and the third one is pulling the chair. In all three of these images, you find the person holding on to something, either pushing the chair or pulling the chair. Whereas in this picture, you see apples on a tree falling down towards the earth. No one is there. They just fall and they fall vertically downwards onto the ground, into the soil. So this brings us to different types of forces. And one of the different types is contact and non-contact force. Now, the first picture of carrying, pushing and pulling is a contact force, whereas the second one of apples falling to the ground is an example of non-contact force. Now, what is a contact force? This force occurs due to the contact between two different objects. The man and the object he is carrying, the man touching and pushing the chair or the man pulling the chair. So there is a contact between the object and the person. Whereas the non-contact force occurs due to attraction or repulsion between two objects, but there is no contact between them. The apple falls to the ground without having any contact with anyone in between. In a contact force, there is no field linked with the contact force, and in non-contact force, there is always a field linked with that force, meaning, either a magnetic field or a gravitational field, whereas carrying, pushing, pulling doesn't have any magnetic, electrical or, gravitational field. Examples of contact forces are frictional force and muscular force, whereas gravitational, magnetic and electrostatic forces are non-contact forces. Look at this picture. The first image shows us two people on either side of the seesaw, apparently both of similar weight, and therefore the seesaw is level. It doesn't go up or down on both sides. In the second image, we see two lesser weight people on the left side, and on the right side a person with slightly more weight, but they balance each other. The weight of the person on the right will be equal to the weight of both those on the left, and again the seesaw is balanced. It's neither moving up nor down on the left or the right. And in the third image, you see three people on the left and two on the right, and apparently their weight is balanced, and so there is no movement of that seesaw. And in the next picture, you can see that the seesaw is totally onto one side. It has come down on one side because on the right we don't have any object, and on the left there is an object placed there. This brings us to another classification of force, that is the balanced and the unbalanced force. Now, when forces exerted on an object are equal in magnitude and opposite in direction, that is a balanced force. Now, the total or net force is zero, and a balanced force does not change the state of rest or the movement or motion of the object, that is, the object just doesn't move. Whereas in an unbalanced force, the forces applied are unequal. Therefore, the net force or the total force is not zero. This unbalanced force changes the state of rest or movement of an object, and therefore the object moves. Now, another good example of balanced and unbalanced force is the tug of war, the game called the tug of war. Now, if we have two teams who are applying equal force on that rope from the right side and the left side, then the net force becomes zero and the rope doesn't move. But sometimes you have one team which is stronger and applying more force than the other team. So in that case, suppose we have the right hand team which is applying more force. That becomes unbalanced force, and that rope now starts moving in the right direction. And so the object or the rope moves. So for balanced force, equal force is applied in opposite directions and the object doesn't move, whereas in an unbalanced force, unequal forces are applied and the object moves.